In this video, I'll be introducing the double integral. So let's say we have some function of two variables, right? Takes in two inputs, outputs a height. So you have your XYZ plane. This is X, that's Y, here's Z, right? And you take an X value and a Y value and you output a Z value. Maybe it'll look something like this, right? Now, what if I want to find the volume between that and some surface on the XY plane? Right? Find the volume between that region on the XY plane and the surface. Well, let's go ahead and draw that little curve on the XY plane. It'll look maybe like that. Okay? Now what I'm going to do is I'm going to divide it into tiny little boxes. Right? I'm only going to do it like that. Now these boxes are going to be dx, right? A little change in x by a little change in y, right? They're going to be dx by dy. So if we have that, that's going to be dx by dy, the area of that little box is going to be dx times dy, right? But what's the height? If I'm going to take a little box and move it up to a height, what's the height going to be to get that volume of that rectangular prism? Which can be f of xy, right? So that's what we just said the height was. Right? We're going up to the surface, getting that height, we're multiplying it by a little area, a tiny little area right there. So what do I need to do over the x values? Well, I need to sum over them. What do I need to do with the y values? Well, I need to sum over them. Where do I sum over these x and y values? Over the region R. I'll call it R. Okay? This is how we write it. Okay? So now, let's get an example. Let's do f of xy equals x plus y. Nice simple function. Okay? Now let's take the region to be the line y equals x from x between 0 and 1. Alright? What is now that's just going to be the line, and then we're also going to have the region bound between that and y equals 0. Okay, so let's draw this out. So right here is the xy plane. And then I draw my line y equals x. Right? Now that goes between 0, 0, and 1. I'll call that a 1 right there. Okay. So now we need to integrate over this region, that region right there. So how would we do that? Well, you can see the y value starts off, if I look at a specific x value, the y value starts off at 0, and it goes up until that specific x value. So we have it going from y equals 0 until y equals x. Now where is x going from? Well, I'll move these into this part a little bit. X is going from 0 until x is 1. We have that right there. Okay, what's our function again? x plus y. Now I'm going to write dy dx because right here we need to integrate over y first. Okay, let's evaluate this integral. What's the integral of this dy? Well, we can get that out. X equals 0 until x equals 1. Okay, I get x times y, right? X times y, because x is a constant in this case. Because we're looking at constant x and moving along in the y direction. X times y plus 1/2 y squared. And we're evaluating that at from 0 until x. Okay, so we plug in for y, x. What do we get out of that? Well, the integral from x equals 0 until x equals 1. And then we're going to have x times x plus 1/2 x dx. What's that going to give us? Well, it's going to be the integral from x equals 0 until x equals 1 of x squared. Okay, so that's going to be x squared plus 1/2 x squared. That's going to be 3/2 x squared dx. Then what you're going to get from that, you write it down here. So you add 1 and then you divide by it. Well, you get 1/2 x cubed evaluated from 0 until 1. That's going to be 1/2. So let's remember what we're doing here. We have our xy plane here, and we have x plus y, the plane. It's going to look maybe something like that. Okay? And we're doing it, and we're looking at the area of that in that little region between the two curves. The volume, sorry. So, hopefully that made sense and you can see all the work.